going to tell you some technical details about the electric e107 from Fendt, a 75 horsepower electric tractor. I think Fendt has put a quite nice animation on our website to explain what is underneath the hood. So let's have a closer look. First, of course, to take the cabin off. Then we have a much more clearer view about the rear wheel drive. Here is the Vario transmission, the electric drive in front and the battery pack. Here you see the electrical motor of 55 kilowatt, 75 horsepower, but it has peak power up to 66 kilowatt hour. And on top of it, it is a pre-fitted assembly with all the batteries in it. As stated here, it's a high efficient electric motor. High efficient, especially compared to a diesel engine. An electric motor has some efficiency about 95%. So all the electricity from the battery that you put into this motor, approximately 95% comes to the output shaft, to the Vario. And that's a main big difference compared to a diesel engine, where a diesel engine only has a efficiency approximately about 35 to 40%. So from each energy, 10 kilowatt hour of energy of diesel fossil fuels that you put into the cylinder, only 4 kilowatt hours comes to the output shaft. This battery, if you put 10 kilowatt hours in it, you get 9.5 kilowatt out of the motor on the Vario transmission. So that's a big increase in efficiency, and that's also needed because you want to take as less battery power with you as needed. Another advantage of this system is that they have a dual output shaft. So they have one output shaft going to the Vario, but they have another output shaft going to the front, and with a gear ratio it is propelling the front PTO. So with one motor you have two output shafts for propelling a full 100% of your power capacity to the front PTO, to the rear PTO, to the Vario transmission and to the hydraulics. The battery pack, which is on top of the system, is a pack from BMZ from Germany. Also, this tractor is fitted with special tires to have less efficiency loss on the road. Then, if we zoom out a bit more, we go to the grid connection, to the Type T2 connector or the CCS. It's both a combination. You can charge it with Type 2 and you can charge it with DC CCS. So if you charge it with the Type 2 connector, which is the slowest from both versions, then you need the onboard charger, which is on top of the battery pack. This AC charging is able to have 22 kilowatt, so in approximately 5 hours you will be able to charge the full battery pack. The energy will go through this port to the top, and this module will convert the alternative current to direct current into the battery. A battery is always a direct current energy source. If you want to do fast charging, then you need a different type of charger off board of your vehicle. So at your location you'll need a DC charger, but you are able to put much more energy in this battery pack. Because an AC charger, you always want to have it as small as possible, as light as possible, because it's on the vehicle. But if you go off the vehicle, you can have a large volume of charger, which has some cooling fans in it, and you can also hear it if you're standing next to a DC charger. The fans make a lot of noise, but by that point you have the AC alternative current of your machine being converted into direct current, and the direct current is going straight from this CCS charging point into the battery pack, which is explained a bit more here in this bottom picture. This is AC current. Let me put my picture a bit to the side. Here you see AC charging going into the plug, from the plug to the AC charger, direct alternative current going to direct current and charging the battery. And it looks with DC charging like this. On the bottom points the energy goes, a plus and minus pole is in the connection, and it goes straight to the battery, and the battery is being charged. This way you will be able to charge it in 1 hour, and in the AC configuration you will be able to charge your battery in approximately 5 hours. So, going back to the tractor technique. All those components which run at high voltage will need to have cooling, because everything which runs on electricity, especially on high power electricity, gets hot and have a few percent of loss. But if you have like an AC onboard charger, 22 kilowatt, if you have a loss of 10%, means you have 2 kilowatt of energy loss, which is approximately the same as a water cooler. So battery cooling package is needed to cool the whole system down. Here you see a cooler at the front on top, and there's also in the front also a cooling package. One is also for the air conditioning and the other is for the water and oil from the transmission and the hydraulic oil which is being cooled. Also one expansion bottle in the front, and what we can find out here is that the cooling package is a bit bigger in size than it previously was with a diesel engine. With an electric drive, your cooling may not exceed 45 degrees Celsius, which is way less than 80 till 100 degrees of Celsius on your diesel engine. So if it's outside 40 degrees and you still want to have your system full running, you need to have more capacity to cool the hot air down to 45 degrees, which is allowed in your system. And Fendt has found a clever solution for it, because they're using active cooling from the air conditioning, both on the battery as on the components, so they can cool down the water temperature further down than the ambient temperature. One other component that stands out over here is the heater. I assume this is the heater, the DC heater, running also on the battery voltage of 600 volt, and it's heating the water for the cabin. So as you want to have your whole electricity system to be running lower than 45 degrees, you want to have a cabin temperature which is nice, comfortable. So in the cabin they still heat up the water until approximately 80 or 90 degrees, so the normal fans, the blowers in your cabin will have the right temperature. What I miss over here is the torque converter, the inverter, which causes the DC direct current power to the alternating current power needed for the electrical motor, for the torque and the right RPM of the motor. If you run on high amps, high power for your electric motor, you get an electromagnetic field, EMC it's called. So that's why you want to have the cables as close as possible between the battery and the electric motor. That's why you don't see so often that an electric vehicle has batteries all over the vehicle mounted. You want to have one pack as close as possible to the motor. One thing what I cannot find in these pictures is the DC-DC converter. That's a converter needed to have 12 volt system on board of your tractor and for your implements. Normally this is done by an alternator, but as we don't have a diesel engine anymore, we need a different technology to create 12 volt. That's called a DC-DC converter, which turns the 600 volt from the battery into 12 volt for the electric system. The whole cabin is still running on 12 volt. You don't want any active high volt components inside your cabin just because of safety. I think just in this presentation I took you through most of the components, most of the changes. Of course, big changes, there is no diesel tank anymore, so that saves a lot of space here. As you know, there is no batteries mounted underneath the stairs here or on the other side of the tractor. The hydraulic system is still on the other side of the tractor. We still have a front lift, we still have a rear lift, we still have the front PTO, we still have the rear PTO. On the back there is nothing changed, so you can still use your implements as you are used to. You can still use this tractor as you're used to. At this point it's only available as a V version, the Vineyard version, but from 2025 on probably there will be an S version as well, which is a bit wider and more used in, can be more used in agricultural applications. So we are looking forward to it. I hope in this video I have given you some more explanation on what is underneath the hood of this electric tractor. I hope you like it. If you like it, give me a thumb up or a like. It will help me to create more videos if you like it. Thank you for watching, and maybe till next time.